Now we will do the gold leaf experiment, Rutherford's gold leaf experiment, also called the alpha particle scattering experiment. Okay. As I said that Rutherford took a gold leaf. Gold is the most malleable metal, so the thin sheet of gold, leaf of gold, it is thinner than this paper, and the thin sheet of gold was taken and he bombarded the thin sheet of gold with alpha particles. Now what are alpha particles? Alpha particles are doubly charged helium, double positive helium. Now how is it made? This helium is neutral. Helium contains what? It contains 2 electrons, helium neutral atom contains 2 electrons, 2 protons and 2 neutrons. So when the 2 electrons are removed from a neutral helium atom, then what happens? It acquires 2 positive charge. 2 electrons are removed, so what is left? Only, there is no K shell now. From the K shell, the 2 electrons are removed, so it is left with in the nucleus, initially it had 2p, 2n and in the K shell 2 electrons. Now these are ionized, the 2 valence electrons are removed. Now it has got 2p. Neutron does not have any charge, so it is only the 2 protons. So helium becomes doubly charged, 2 positive charges on helium. So this is alpha particle. This is alpha particle. So he bombarded this sheet and only one atom is taken over here, for example. So what happened? What did he notice? He noticed that most of the particles passed, most of the helium particles passed undeflected. They just went across and made, this is the circular zinc sulfide screen over here. They made scintillations over here. And most of the particles, they straight away went and hit the screen. Only in the center there was a shadow, nothing could be seen, no scintillations in the small zone, a very small zone, there was no scintillations over there, did not observe. A very few particles made small angles and some 1 or 2 in 1,000 made a greater, means was deflected to by a greater angle, and just 1 or 2 went and hit this object in the center and boomerang back, took a U-turn and came back in the same direction. Now the experimental material is what? Doubly charged, double positive helium, that is alpha. So if it is being repelled in this way from the center, that means this part is also positively charged, that is why like charges repel each other. So helium particles hit this target and came back. Some were deflected, those particles, those helium particles which were passing very close by to this central zone, they got deflected. Because this is positive and helium is also positive, it got deflected. It made an angle and hit the screen over here, but this was very few in number. Some to a smaller degree and some which hit the target directly to a greater extent, to a greater angle, and most of them passed through without any hindrance at all. So what did he conclude on this basis? Just a few particles were deflected, most of them went without any deviation, and 1 or 2 made a U-turn and boomerang back in the same direction as it was traveling. It came this way, made a 360-degree angle, went back in the same way. Now these are the conclusions that he drew. Atoms contain a large empty space. It has to be an empty space. That is why the particles are passing unhindered and hitting the zinc sulfide screen over here. There is a positively charged mass at the center of the atom, which he called nucleus, in which this mass of this nucleus is a very, very dense mass. This nucleus is a very, very dense mass, and it does not allow anything to pass through it. That is why a small shadow over here, very small shadow. So the size of the nucleus is very small, and positively charged particles are at the center of the mass nucleus, in which the center of the mass is concentrated. The whole mass is concentrated in this nucleus. So it is a concentrated, positively charged, small mass. The electrons revolve around the nucleus at large distances from each other. from the nuclei. The electrons are at large distances from each other and they are continuously revolving. Next, electrons revolve around the nucleus in circular paths called orbits. They are in a state of continuous motion. That is why these alpha particles did not hit the electrons in these paths, in the orbits. They are in a state of random motion and they are far apart from each other and they are far from the nucleus also. So electrons, atom as a whole is electrically neutral. Why it is electrically neutral? Because the number of protons present here is equal to the number of electrons, right? Then the electrons revolve around the nucleus in circular paths called orbits. Now the other thing is that the force of attraction between the positively charged electron, or negatively charged electron, the force of attraction, these, if they are in orbit, suppose circular paths, here see, they say the electrons are in circular paths, they are moving around this. So because any charged particle moving in circular paths, they feel the force of centrifugal force. Centrifugal force means being thrown away from this at a tangent. So this is, the nucleus is positive, the electrons are negative, the electrons are pulled by the nucleus, the positively charged, but then how is it staying in place? Why is it not falling into the nucleus? Because of this positively charged, this force of attraction is counterbalanced by the negatively charged, by the centrifugal force of the negatively charged electrons. That's the Rutherford's model.